I should take this opportunity to thank you all for the support on the on the Discord. It's very much appreciated. It's very impressive response times.
Very much to you, Benjamin. You are really awesome. I mean, always helping and always sharing. I mean, it's a pleasure having someone like you in Discord.
Well, yeah, thanks. Yeah, we very much appreciate it. I'll talk a little more about what we do later.
Hello. Oh, I see guys here from DAGsHub. Hi. Okay, Mert, tell me how to say your name properly.
Hi.
Mert.
Mert, is that right?
Yeah.
Cool. Ah, Simon's from DAGsHub's here too. Cool. All right, let me let in some more people. Hey, Dimitri, how are you? Feel free, everyone, to
well, thank you.
Unmute your microphones and say hello. Mert, say hi. Where are you from?
Hello, my name is Matt and I'm from Istanbul, Turkey. And also I am first grade student, freshman student in university and machine learning engineering intern right now in the startup in Istanbul.
Awesome, great to have you here. I'm gonna let the team introduce themselves too today. We'll start with Dave.
Hi, everybody. I'm Dave Barenbaum. I am a technical product manager for DVC. Yeah, I have worked as a data science ML practitioner for a number of years before coming to work here, and used DVC quite a bit in my own projects prior to joining. So nice to meet everyone.
David, you want to introduce yourself?
Me? Yeah, sure. I'm David. I'm one of the maintainers of the CML product at the Iterative. I have been doing machine learning and AI basically for the last 7 years, I think. Mostly, but this is the first time I had the opportunity and the chance to contribute in an open source project. And it's really exciting and super happy about.
Cool. Thanks. How about Pavel? You want to say hi?
Sure. Hi, my name is Paul. I come from Poland and I'm one of the DVC maintainers. And as David mentioned, yeah, I also contribute to. I like to contribute to open source, and DVC is actually the first project that I contributed to.
How about some of our guests here? I see Nir is here. How are you?
All good, Jennifer. How are you?
Good, good.
Nice meeting you. Hopefully next time we will be in person.
That would be cool. I can't wait for that time.
Definitely. Hoping for COVID to pass.
Yes. I see some new faces. Is it Maimuna?
Yeah, hi. My name is Maimuna, but I usually go by Mai. I'm a machine learning engineer at a startup called Globality. And we use DVC to track our, machine learning experiments and, kind of a few ETLs. And so I thought it'd be really cool to actually join in on this office hours and, kind of get more involved in the open source community itself.
Cool. Thanks for being here.
Well, thank you.
All right. Well, I'm going to get started. It looks like we've got a good amount now. So let's get started. I'm going to give you a lay of the land. Today, we are going to hear from a couple of people in our community members, which I'm really excited about. First up will be Benjamin Jones. He's been using DVC and CML on his team. We will take some questions for him after that. Following this, we will have Puneeth Pai's presentation on CD for ML using DVC pipelines, Jenkins and DAGsHub. And we will immediately follow that with David Ortega discussing the new features of CML pull requests, because those two things are kind of related to each other. And so we can see both types of approaches, and then we can kind of have like lots of questions and discussion around the different approaches and the topic. So today we really want to work toward having a discussion and a conversation. So please interject and ask questions, or you can raise your hand by hovering over the bottom of your Zoom page, and you go to the reactions and you can raise your hand there and I can call on you if like it's getting to be noisy. So we can do it that way too. But we really want to like make sure that everybody is heard and has a conversation. We're all here to talk to each other in this little virtual space that we have. And so with that, I'm going to hand it over to Benjamin Jones.
Yeah, thanks, Jen. Yeah, hi everyone. My name's Ben. I'm from London, and I work as an MLOps engineer at the UK Hydrographic Office. And Jen invited me today to talk a little bit about how our team are using DVC CML. So yeah, I'll give you a bit of a background about what we do and how we're using it. So the UK Hydrographic Office, it's sort of like a mapping organization. It's part of the UK government, and so we map hydrographic information and geospatial marine information for mariners and for the UK Ministry of Defence as well. So some of what we do is a bit sensitive, and at times I might not be able to talk about it, but I'll try and do my best. So we'd have a data science function, and so we have a number of projects that really benefit from DVC and CML. So the one that I'm working on most closely is to classify the seafloor. It's called bathymetry, and so I won't talk too much about it, but I have some photos that might actually help a little bit. So if you, maybe I'll paste them in the chat, or I can just put the link in the chat. Okay, so we want to produce a 3D map of the ocean's surface, so the ocean seafloor surface across the entire globe. It's quite an ambitious task, and it benefits a lot from machine learning. I don't know if you can see that image, but it's basically it's like a 3D surface under the ocean. Unfortunately, it doesn't always look like that. It often looks like this image that I pasted as well. So typically, it's very noisy data, and you normally have many sort of hundreds of people, specialized, skilled people around the world who can distinguish the noise and the surface from those sensor measurements. So this is a huge scale project, really. Is hundreds of gigabytes, terabytes of data that need to be cleaned. And we've developed a few different algorithms, a few different methods that are good at different things, at cleaning different types of seafloor data. Also, I'm trying to keep this quite formal, so please do shout out if you've got any questions. But so broadly speaking, before DVC and CML, the way we work is it can be difficult at times. So a lot of what we were doing originally was on premise, and so we had servers on premise that we would SSH into, and we have this sort of terabyte storage of raw data, and we would need to sort of move that data around on these different servers. Some of them have GPUs, some of them don't, some of them have really high RAM capacities. Sometimes they're not available and being used by the teams. So we would have to move that data around manually, and that was quite a large effort. Then there's data preparation, which could take maybe 10 to 15 hours to run. And so DVC really helps us there. It helps us synchronize all of that data across our different working environments. And then manage the outputs as well. So manage those models. It gives us huge reproducibility that we just didn't have before. We might have maybe 3 or 4 candidate models, and each of those might have 30 or 40 different experiment branches on those. So you can imagine managing all that data across different projects and different teams. It's an absolute nightmare, and it's become so much easier with DVC. So we're really, really pleased to use it. A bit more recently, we've been exploring CML as well. So as I mentioned, the compute available to us is a little bit fragmented. Sometimes you'll often see in the morning someone will ask, is the GPU machine being run today, or is it available for me to use? And that's a typical sort of problem when I arrived, certainly at the team. So CML is a perfect use case for that. We get the ability to just design our experiments, run them really small scale on our local machines, and then push that code up to our GitHub account. where it's picked up by CML. It creates a runner, a GPU runner in AWS. Obviously, we can specify the capacity and the size, and runs our experiment for us, and then saves the results using DVC, saves those to the SAMs and S3. And then we get to see the results as metrics and graphs that get pushed back to our PR. So that's it's the standard sort of CML case, but it's it's really excellent and helps us manage those tons of experiments we're trying to run at any one time. Yeah, I guess that's broadly it. I don't know, Jen, if you had anything else you wanted me to talk about it, or any other questions from anybody?
I mean, that's great. Does anybody have any questions? I think this is really cool. I don't know if anybody opened up these pictures. They're pretty neat. But yeah, does anyone have any questions on like how he's got everything set up, or anything in regards, anything that relates to your own experience on your teams or from our team? Do you have any questions for him? I know that Benjamin was in Discord, like going back and forth a lot with the team on everything. So that was really cool. It's nice to put a face to a name and learn about your team. That's really cool.
Yeah, that's great. Thanks. Thanks for that comment, Guy. I'll have a look at that. I think one of the things that we're working on now, and maybe we're sort of trying to bolster on to CML, is something I see actually. So we have the CML TensorBoard dev experiment, I think, that you guys have, and I really like that idea. We can't use it because TensorBoard dev is a publicly hosted application, so that link is not secure, can be used by anyone. So we're looking to do something similar to that. So I don't know if anybody's had experience with that before. Something like hosting a Jupyter notebook privately with a link that comes back in the CML pull request, or a TensorBoard, something like that would be really helpful to us. So if anybody does know that, please do reach out. Yeah, that's great. Thanks, I'll have a look. Yeah, and feel free to speak up. Who suggested that? I think it's a private message to me from someone called Guy. But
yeah.
But
It's not related to CML, just something you might want to look at, completely unrelated.
Gotcha.
Sure, I appreciate it. Yeah, thank you. Does anyone have
any
Great, well, I'll hand back to Jen if that's everything. But yeah, otherwise, please do ask. Okay. Any other questions for Benjamin?
I had a question about how you organize your different model variants. You mentioned you had a couple different model variants, and how you organize those. Yeah, that's a great question, actually. Something that we're working on now. So at the beginning, like I said, we had 3 candidate models. Broadly speaking, there are 3 good ones. And we had different branches for those different candidate models. And those branches then have sort of sub-branches of the different experiments that are trying to improve those candidates. And that actually became quickly unmaintainable because the three branches contain lots of common code, and so when we update one of those branches, we then have to update the others, and then all of the subsequent branches that are branching off of those. So it became a bit unmanageable. So we're actually transitioning now to remove that tech debt and to create more of like a monorepo approach, where we'll have sub repos or subdirectories that contain each of the different model candidates. But they have common components, like the transformation pipelines are largely similar. And so we're looking to use the DVC. DVC has support for like monorepos, where you can have different pipelines within the same repository. So we're actually transitioning probably today and tomorrow into doing that. Cool. We'll have to. Does that answer your questions? Does that answer your question? Yeah, it does. Thanks. Anyone else?
Just to chime in, on our team, we use subrepos very extensively, but then we always run into like a few weird edge cases that perhaps we don't know how to solve properly. Like one of the things that as a small thing, like we haven't been able to do. I don't know if it's been updated within DVC, but when we have subrepos, we can't automatically use the Git hooks as well. So when you have you do your DVC push, or DVC commit or Git commit, to make sure that those 2 commands are synced. But we found that when you have subrepos and you have within one main Git repo, then it tries to do it for the Git repo, not for the sub repo. And so we haven't been able to figure that out. And I apologize if I didn't explain that properly. But that was one thing. So right now people have to just remember to DVC push, you know, in order for data to be stored. That was one thing. There's I can't recall, but yeah, but I would be interested to hear how you guys get along with the sub repos.
Cool. All right, now we're gonna have to both your teams back, and you can tell us how to go.
Absolutely.
Mai, are you in Discord too?
I joined it recently for the first time, but so I'm still trying to get used to how it all works.
Yeah. Okay.
I think I did have one more question, but it's not a fully formed question, but I recommended DVC to one of my friends, and then she was asking me, because she because the idea is that when you have like a DVC run command, it owns that directory. And so whenever we recreate it, it might delete it and then, add, the latest version of the model or the file. But instead she had wanted to iteratively add, in like a models directory, just iteratively add different models without deleting the previous one, right? And there wasn't quite a way to do it properly. I mean, you can use outs persist so that the model directory doesn't get deleted, but there wasn't we weren't able to quite figure it out at the moment. But I don't know if that's a feature that if that principle goes against what DVC is trying to do, or if there's a way to do it, and I just haven't figured it out yet.
Dave?
Yeah, I would say, feel free to, either engage in Discord or open a GitHub issue or something, but that is an issue that's kind of, I wouldn't say it goes against what DVC does. It's more of just, it's not really the typical DVC pattern. And so we haven't quite figured out like the best way to handle that type of use case of sort of iteratively adding to an output, right? Like she wants to track the whole directory, and then she wants to be adding another model file to it every so often.
Yeah. So that, she can just see all the different models under one directory and then do whatever she wants there, as opposed to having to go back to a different commit.
Yeah. If you want to reach out offline, I can probably point you to some of the discussions that we've had on it, and happy to discuss it more.
All right, cool. Thanks.
All right, thanks, Mike. All right, well, with that, we will go to Puneeth next. So Puneeth, you ready?
Yeah.
Awesome. You've got your shirt on. Nice.
Got delivered on that. So I'll share my. Okay. I'm Puneeth. I'll be talking about how we implemented CD4ML with Jenkins. So CD4ML stands for Continuous Delivery for Machine Learning. It comes from Martin Fowler's blog on ThoughtWorks. So basically, I'll be explaining how we use Jenkins to run DVC pipeline. So a bit about me, I'm Puneeth. I'm working as a machine learning engineer at ThoughtWorks, India. So you can follow me in GitHub link. So before we get started, I'll go through the agenda. So first, I'll talk about what were our project MLOps needs. Then why did we use Jenkins? How did we implement it? And what are the few use cases we were able to address with this implementation? And so our MLOps needs. So our project had 4 to 5 data scientists working on model for 3 to 4 different countries. And also in each model, there were sub parts which were owned by different data scientists. So we needed to have seamless collaboration between multiple data scientists. Of course, reproducible of ML experiments and data model tracking was there. Then since we all started working from home due to this COVID situation, training of models or getting data back and forth between our local and cloud was getting huge network, consuming huge network bandwidth, and also was not feasible. So we wanted to have remote model training and also better pull request review process. So I'll talk about what I meant by that, how pull request review is different in machine learning versus software development projects. Looking at all these needs, we can see that CML and DVC are amazing solution for this. Even though we had GitHub Enterprise in our client, it was kind of new to them. That's why they had disabled us from using GitHub Workflow or GitHub Actions. So they were still under security review. But on bright side, Jenkins was kind of approved by them, and also it was widely used by the community. So that's why we kind of started using Jenkins for this. So implementation wise, this is how our standard Jenkins pipeline looks like. This has been defined using Jenkins 5. So you can see that first we'll be running unit tests, then followed by linting, and then DVC specific stages. So you can see my mouse, right, when I'm hovering.
Yes.
Yeah.
Okay. Yeah. So update DVC pipeline is the stage where we run the DVC pipeline. To be able to run it, we should download all the previous data and its version. So we have sync DVC remote. To be able to download data or model, we need to have a credential setup for DVC. And once the DVC pipeline has been run, it will create DVC log file changes and metrics file changes, which we need to commit back so that the experiments are kind of safe. I'll go in depth of a few DVC specific stages and what are the nuances we needed to handle. Other stages I'm skipping. So DVC specific stages. So you can see that first we sync the DVC remotes. To sync the DVC remotes, like downloading the data or models, we just have to do DVC pull. But you can see that we were doing DVC pull from Jenkins local, then DVC pull from origin. I'll explain that. Like when multiple people are working and submitting their jobs to Jenkins, you can see that there can be n jobs running simultaneously. Each job pulling the data or model from your S3 or DVC remote can increase your network bandwidth and also increase your build latency. So what we did was we had an idea of using Jenkins local cache as a secondary remote. So if the files are missing from this local cache, only then it will pull from S3 or your actual remote, and it will sync these two so that in future jobs it's available here and our build will be faster. So that's how we kind of used S3 or DVC remote as primary and Jenkins local cache as a secondary. After we downloaded the data, we had to kind of reproduce the pipeline. So we have to just do DVC reproduce. After DVC reproduce is successful, we'll do DVC push. So you can see that we are pushing to both a local cache and also origin. In the end, in line number 12, we can see that we are also printing DVC metrics diff. So this helps because in the Jenkins log, we can see that the metrics are compared. So when you are kind of approving the pull request, you can always see this log and compare the results before you merge the pull request. So we had one question like when to run the DVC pipeline. So there was kind of several options we had to consider. So when you run DVC reproduce command, it will kind of modify DVC log file and metrics files. You have to just commit it afterwards. But the question was when to run DVC pipeline. So should we run it for all the commits or only for the master branch, or should we set up some manual trigger in Jenkins and based on that, or should we have a special commit message syntax like run experiment, push experiment, something like that, or based on pull request? So we tried to put pros and cons of each of the methods. So when you run DVC for all the commits, the pro is that you will never miss any experiment. But cons are like it will increase your build latency and it will increase your cloud resource expense. Maybe overkill to run experiments for all the commits. But if you run only for master branch, only master branch experiments are saved, but it defeats the purpose, because when you are raising a pull request and the experiments are not run and you cannot compare the experiments, the bad experiments can slip through your peer review and get merged to master. So if you set up a manual trigger, pro is that decision is with you. Like, you can decide when you want to run the pipeline, but automation is not complete. So there can be room for manual errors. Also, same thing with the special commit message syntax. Decision is still with you, but same thing, automation is not complete. And also it's a injustice to commit message purpose. So when you go back your Git history, you have to understand how the product has evolved. But if you also combine it with the infra instruction or DevOps instruction to run the pipeline, it kind of defeats the purpose. But when you run the DVC pipeline for pull request, you can see that you can compare the experiments before the pull request is approved and merged, and no bad experiments can slip through you now. So cons, we could not find any yet. So same thing, like in summary, for all the branches, we'll run all the stages, skipping DVC pipeline execution and committing back the result. And when you make a pull request, it will run that also. So commit back result looks same. Like if you concentrate on line number 15, we'll check if the DVC log file has changed, and only if that has changed, it will commit back as a Jenkins user. So it looks like this. So you make a pull request and wait for the Jenkins to execute the pipeline. Once the DVC has run the pipeline successfully, Jenkins commits on behalf of you and points back to the parent commit, which it used to run the experiment. So you can see that the pull request will be updated, and you can review the experiments and compare the results and then approve the pull request. So some of the use cases we addressed were like same thing, like we wanted to use Jenkins for remote training. So data scientists can work on creating experiments, changing logic, and committing the changes to their repo. From there, Jenkins takes up the job and runs the experiments for you. Once Jenkins commits back the results, you can see the experiments in the experiment tab. Oh, this is like when you use DAGsHub, but you can always use Jenkins logs to see the experiment and compare it. So this is the advantage of using DAGsHub, where we can see all the experiments and approve the PM. Transparency in pull request review. So difference between software development, pull request review versus machine learning is that in software dev, you can verify the code changes and ensure that all the build or test cases are passing. It's not enough with respect to machine learning, because there can be changes in data, changes in model logic, and so many things. So to increase the transparency in pull request, you have to compare the experiments to better understand how the changes are affecting the current state. So experiment comparison is the way to go. So in summary, CD4ML has been implemented by DVC using CML on GitHub, GitLab, Bitbucket. Since we had a restriction, we implemented the same with the Jenkins. And Jenkins kind of has a plugin to communicate with all of this, so you can use reference. Yeah, so all the details has been kind of published in 2-part blogs in DAGsHub blogs. You can follow it. Yeah, this is the original CD4ML article, and stuff. I think that's it.
This is really cool. You know, a lot of my team is, we were discussing kind of, once you have DVC for experiments, how to integrate that with, we're using like Circle CI, not Jenkins, and AWS is our cloud remote storage. But yeah, but the fact that, how you've done it with Jenkins, that, I don't know, I think it's really cool because that's kind of what we've been discussing. And so already thinking of, can we somehow, yeah, how we would be able to implement it on our end. So yeah, I'm definitely going to check out those links. So thanks.
Yeah, thanks.
Yeah, thank you for sharing. That was really interesting to see how you did that. I guess I had one quick question around, are you only using this process for experimentation, or also does this extend to your production automation?
Yeah. So we have multiple Jenkins pipeline defined for that. This is mostly for doing collaboration in between data scientists and saving the experiments. Once you have the experiment or thing you want to productionize, it goes in a different branch, and that has a different logic to productionize it. That hasn't been explained here, but yeah, this is to kind of increase collaboration and smoothen the continuous integration process.
Gotcha. Yeah, I've been brainstorming on my end with our processes at our company to see if there's a way, or if anybody's had experience with demonstrating kind of using Git and DVC also as a kind of production model registry. And my initial concept involved kind of having a dedicated branch that you would commit to, maybe on a scheduled fashion or whatever your training triggers are. But yeah, I'd be curious to hear from anybody if you've had experience trying to do that and keep track of all of your artifacts just using the tools of Git and DVC.
Yeah. So how we were able to do it is like we had a different Jenkins file defined for this continuous delivery process. So data scientists used to collaborate and finally tell this commit or this tag we want to productionize, and based on that trigger, this separate Jenkins pipeline will be executed and it will update in the production. Cool. Yeah, but for this, it's out of scope. So.
Sounds good. Thanks.
Thanks, Puneeth. I'm going to let David go to discuss his CML pull request now, because this is kind of all in the same relation, how we do it with CML, and then we can all ask questions on how to solve and have a discussion. So I'll turn it over to David Ortega now.
So what is CML PR? I mean, basically when we use mostly DVC, and there is at some point that we need to maybe commit some files that is appearing in our experiment, right? Like dvc.log. And it's a very recurrent question that we have, like how to handle in CML dvc.log. And CML PR, what it does is actually, it's a very simple command, and that is actually allowing you to commit all the files that appears in the run of your experiment. As you see, it's very easy to use. It creates a new branch and a new pull request, committing the files, and it's very easy because it accepts a glob pattern, so you can specify like all the JavaScript files, so multiple glob patterns, and it's going to return you a URL which is very CML friendly report. So can you see the next screen? Yeah.
Yep.
So one of the biggest questions that we had a lot is that how do we bootstrap our project that use your CML GPU runner in AWS and commit DVC log, and because we cannot do that locally, and we have been always like bootstrapping like the first run locally and then the experiment in the CI. So with CML PR, actually, you just run your experiment, then you have your DVC log, everything that you have to commit and push, and our bot, Oliva bot, is going to generate that commit, that branch, and it's going to create a pull request for you to review and then for you to merge. So as we have seen, the simple idea of go straight away and commit is very doable, right? I mean, I can do my code in the CI and I can do the commit and push everything. The problem comes just because if you do multiple commits, for example, you are in experiment 1, and you do like 3 commits, and you are generating multiple parallel runs, which are not deterministic, and then you have a lot of conflicts that you are going to rebase, or you have to. There is a lot of conflict at that stage, so it's not going to probably save the world for you later on. So here, CML PR generates all these PRs, and for every single commit is going to generate that branch to that specific commit and the PR that you can then later on review. This is also very convenient when you're working with a team and they don't know what you are doing right now. For some reason, they do a commit and then you need to, with this, at least you can figure out how to resolve this. So also one of the benefits of CML PR is that the CML send command now follows the original branch, even with the new created branch. And this is super cool because actually, if you see the both samples, the CML pull request link is at the top or in the bottom. So what does it mean is that in the workflow, you don't have to take care of where you are going to do the CML PR. You can use it anywhere, so it's like some mind liberation, right? You don't have to guess where and when. It's also CI friendly. You have CI skip and multiple runs. Is green. What does it mean? It means that actually you can trigger the same multiple events can trigger jobs in the CI with the same shot, right? So this means that if that happens, you are having the green light, because what is going to happen, CM PR is just only going to create a new branch just in case it's not created. And in case it is, it's returning you the link to the pull request. And if the pull request is actually closed, it's going to open one again for you, like any other tools, like link tools that you may find in GitHub. So here there is a repo we have been using. You can see it here, DVG Ortega CML PR test name. Basically, if you see it, we bootstrapped this. The committers of the first one is the Oliva bot, so you can see the 3 commits. The 3 commits were one mine, and then CML PR, Oliva and GitHub Action committed for me and created the pull request, and then we merged. So we bootstrapped the project originally, and then I have the pull request, and I have, for example, an experiment, which is basically where I am. I can do at the same time, I can modify 4 and 30, and it's going to generate, like always, the report, and I can go straight away to the pull request to review it, right? I can go to my report and see, okay, I like this one, this is ready. Okay, I can go to the CML pull request or CML pull. I close this and I restarted again, and it's going to generate a new one, totally ready to be merged. So I can go straight away here if I like what I see, and of course I merge it. It's very simple tool, but I think it's going to be very helpful for someone that wants to commit and save their work and commit back the work in the CI. So that's essential.
Great. Thanks, David. So does anyone have any questions for David and Puneeth and your situation and how it relates to these things and how to get your workflows going?
Is it possible to auto-merge that PR? We do something similar, but we just use a separate GitHub action to commit the dvc.log file to the branch that we're in, and then just to push that straight up. And because this experiment branch is usually almost throwaway, if you like it, unless we accept it. We're okay for that commit to happen.
So the question is, Benjamin, sorry?
Without having to manually click merge.
Yes, I mean, we have the UI, right? I mean, we can go to the pull request and then merge, right? That's the question. So I can merge it right here.
Can it happen automatic? Can it automatically merge when the PR is happy? So without having to manually review it?
So the idea will be like, instead of creating the pull request, will be automatically merge it?
Or after the test pass. Right now, we haven't included that functionality to auto merge after test passing. But I mean, feel free to open an issue on the repository and add that as a feature request if you might find that useful.
Yeah, okay. I don't know if anyone uses Dependabot, but in a similar fashion to Dependabot.
Yeah.
Sure. When Dependabot is happy with the test pass, then the PR is automatically merged. A similar sort of thing is what I'm envisioning.
Yeah, I mean, the thing is we support multiple backends. Like, it's not just GitHub, it's also GitLab and Bitbucket. So if they also support it, yeah. The thing is we have to implement different things for every single one of the Git hosts. So yeah, I mean, we can do one by one though, sure.
Yeah, I don't envy that situation and very thankful that you do so. But I can imagine it is tricky.
That was Casper, by the way. Say hi, Casper. Introduce yourself.
Hello. Hello, world.
Well, does anyone have any more questions?
I have a question for Puneeth.
Great.
So Puneeth implemented this functionality, kind of CI/CD for machine learning for Jenkins, and this is like what CML does. Why don't you wrap up your result and push it to CML, so CML can support Jenkins as well, in addition to the existing ones?
I didn't understand the question. Like, why shouldn't I push the results back to CML?
No, what I'm saying is we have in CML, the CML supports a few providers, right? A few CI/CD system. It supports Bitbucket, GitHub Actions, right, and GitLab CI/CD. It's possible to implement Jenkins there, right? We decided to not implement, but you can you have done this like part of the job outside of CML. So you can relatively easy to provide support for Jenkins and CML itself, kind of contribute code to CML.
Yeah. Sure. I mean, you have done like offline. Yeah.
Almost everything. You just need to like embed the support to CML.
Yeah, definitely. Understood.
So yeah, it will be great if you can do this because then CML will support Jenkins as well.
Yeah. To be honest, I mean, CML could be used here, right? The issue is that the SCM that they are using is DAGsHub, if I'm getting that right. Because I mean, if someone can use actually Jenkins with CML, actually they can benefit from the CML PR. I think if they use GitLab or GitHub or Bitbucket as the SCM. The problem here is that they are using, I think, DAGsHub, right? And we don't yet support them. So and just in case, I mean, anyone who is able to experiment, as Dimitri said, we are hunting for having as many integrations as we could. Jenkins has been always in our pipeline. And I have the question of if you, Puneeth, did you need to have like GPUs or a special hardware? Are you running like the equivalent to the CML runner in Jenkins?
Yeah, so you can have Jenkins runner installed on different instances. So we did have one of the instance which had a GPU and Jenkins worker there. So the master will kind of delegate the job to worker and gets the result. So you can mention like runners tag to each stage, and that particular stage can be executed in that worker.
Yeah, that is actually super cool, because at the very beginning we had also like the checks. I mean, we never speak about the check, which is actually a command that in CML we have available. And the idea here was super similar, right? Like having tests to be passed or to trigger the machine learning check. So that was super cool also.
Anyone else?
I have a broader, less technical, more conceptual question.
Cool.
You know, like what is an experiment within your workflows? You know, how granular before you call it an experiment? How much has to change before it's a different experiment versus just an iteration of the same experiment? And how does that reflect in like the number of pull requests that you open? For example, do you do experimenting locally and then open a pull request, or do you start a bunch of cloud experiments and then let them open pull requests? I like this idea of experiments is, I think, something that is not, people have very different opinions on what an experiment is. And I think that'd be interesting to discuss.
For sure. Who wants to take that?
I mean, we have internal nomenclature at DVC for this kind of thing, and to some extent it's because of historical renaming of subcommands and things like that for backward compatibility. I think when we use the word experiment, we are referring to a commit, which probably changes some hyperparameters. In which case you could have an entire group of commits which change hyperparameters in different ways, and that would be the equivalent of a hyperparameter grid search. But yes, I'm sure you have different definitions of what an experiment is.
Yeah, I can add to this that yes, this is like how we initially thought about experiments, right, and experimentation experience. But in some cases, creating commits for each experiment is a little bit too much, and this is like one of the motivation behind a DVC exp command, right? DVC experiment. When you just do like runs, you don't commit, while DVC still keep track of all your changes. So yeah, that kind of two different types of experiments: your local experiment, right, which is important for you when you do experimentation. And second experiment that you are ready to share with the team. In this case, yes, you are usually like ready to make a commit and sometimes even a pull request. And when we say about experiments in context of CI/CD, it's mostly about sharing. I would say there are two types of experiments. Your experiment that you don't want to share, and most likely you do like 20 of those, or like 200 of those. And then when you're ready to share, you make like one, maybe two commits and push them to CI/CD, Git, etc., etc. It's kind of like collaboration level experiments. In context of CML, it's mostly and it's usually about collaboration and this kind of Git experiments, not your local experiments. But the term is kind of very interesting because, like, you're absolutely right. A different team have a different naming conventions, and also in a different stage of your project, you might have a different conventions and different understanding of experiments.
So then maybe one way to kind of clarify the daylight between these two ideas would be to ask this question. So after you're done with your 20 to 200 local experiments, what uncertainty is left such that you would need to open a pull request and have what is the cloud runner actually running that you haven't already run yourself locally doing one of those experiments?
Yeah, it depends on your workflow in the team, right? Because after running like 200 experiments, you still might be not sure this experiment is the right thing to do. And when you share this result, you need a feedback from the team. Okay, for example, you increase accuracy by like 0.1%, but decrease precision. by 0.05%. Is it a good result? Is it a bad result? Sometimes it's really hard to say. And in some cases, you reach this result because you like modify and tweak data a bit. Sometimes you modify algorithm a bit. And in this case, your team provide your feedback. So let's say they can say, you know what, we cannot sacrifice too much precision for this accuracy. You probably should tweak this a bit, right? And you return back to your kind of experimentation phase. And regarding running and not running, the training phase, it's also like up to you. In some teams, it will be like necessarily to run it somewhere to kind of show final model, which was run not on your local machine. For example, when I was working in a large company, no one will take model from my machine to run it somewhere in like production environment. They will ask me to rerun it on third-party training machine. And this like CI/CD can play this like third-party role. Yeah, so a lot of different workflow, and different teams have kind of motivation to using like one on another. But yeah, but that's very interesting discussion, and it will be great to continue and come up with some suggestions or maybe like a blog post or something. Then when people can learn from different use cases. It will be great if you can share, by the way, what you mean by this.
Yeah, Sammy, how do you think through your experiments on your team?
Well, actually, I just started a new gig, and I'm in the process of kind of rebuilding the machine learning ops architecture. I used DVC at my previous job, and I'm slowly trying to evangelize the new workspace. And I actually, the reason I asked this question is because we kind of faced this conceptual difficulty in the last gig. It was like, what am I running locally? What should I be committing locally? What should be running in the cloud? And we had a pretty good process that worked fairly well for most of our projects, but it didn't actually require anything to run in the cloud necessarily, except as that, like Dimitri mentioned, like as that kind of third-party stamp of approval, proof that it runs. It's not just running on my machine, kind of thing, which I agree is important for reproducibility and all that. But then it introduces this workflow question of what do you commit to your PR and what do you let the cloud run and then commit? Again, a lot revolving around this like DVC lock, and do you commit that or not? Something that we struggled with a little bit. But I think you can get to something that works, but it always feels a little bit like either you're duplicating work or you're intentionally withholding work to make the cloud runner run it or something like that. It was yeah. Anyway. I don't have a good answer, Yeah,
exactly. In general, answer is simple, right? You keep and commit in a local experiments in like DVC for example, everything that is important for you, and you commit and push commits to GitHub everything which is important for your team. Right? Conceptually, it's very simple. The question is like, what is important for you? What is important for team? And this answer depends on the project, on the team, on like different things.
We're seeing that a lot. So we're almost at time, but this was a really good conversation today. I would really love to have more of these conversations like this today, where we understand what you guys are going through and what your team is like, and so that we can know how to improve our tools for you. So if any of you have would like to speak at the office hours and say how you're using it, or ways that you've figured out your workflow, how you've decided, Sammy, what works for you for experiments. And it's great to share that with the community, because some other team that may work for them, whereas another team may need to do it in a completely different way. But there's a different way to use the tools to get there. So I would love for you guys to reach out for me. I'm going to put my info in the chat, and so it's there. Also, there was a lot of good info in the chat today. So I don't know if everybody knows this, but if you click on the ellipsis at the bottom of the chat, you can save the chat. If you guys want to grab that, I'll give you time to grab that before we finish here. But I want to thank Benjamin Jones for presenting today, and Puneeth and our friends at DAGsHub for joining us today. Welcome. It was great to see you here. So thank you all so much for being here. It was a great day, and have a great rest of your week.
Thanks, Jenny.
You're welcome.
Thanks,
Have a good one.
I didn't know
Thanks,
the
everybody.
DAGsHub or Jenkins, but that was a great day.
Thanks, Merritt.
Thank you.
Thanks.